All right, guys. So today we're going to use some of those ideas that we found on Tuesday and Wednesday and apply those to the coordinate plane. So before we do that, a couple things. The first thing is you guys don't have this page in your note packets. I did upload it to the Google Classroom, so if you're able to print, I would suggest printing it off first. If you are not able to print, see if you can open it in your OneNote and write on there, or just get a separate sheet of paper and try drawing everything out there. If there's something that you guys find that really works when I am uploading documents that you guys don't have a physical copy of, please let me know so that I could share it with the rest of the class. So right now we're all kind of trying new things. But first, I do want to kind of review some of the ideas that maybe we haven't talked about in a while to make sure that we have everything that we need before we start this topic. So the first thing that I want to review is how do we find slope? And I'm sure many of you guys remember Mrs. Stollett's beautiful song, but Miss Winkle's not as good of a singer as Miss Stollett is, so I'm just going to write it out. So to find the slope, we do our y2 minus y1 over x2 minus x1. So really what that means is when we have two coordinates, we're just going to name one pair 1, the other pair 2, and we want to make sure that we do the second pair minus the first pair with both our x and our y. The other thing that I want to review is that idea of parallel and perpendicular slopes. So if you guys remember something with a parallel slope, we're going to have the same slope. And if something is perpendicular, we're going to have opposite reciprocal slopes. So what that means, same slope. So if I have the slope, if I have the line y equals 1/2 x plus 4, something with a parallel line would be anything where I have y equals 1/2 x as my slope. And that plus could be plus anything. I could have plus 7 or plus 12 or plus 279. If I wanted a perpendicular line, I would have to have y equals the opposite reciprocal. So first, opposite means we change our sign. So since I have a positive 1/2, my perpendicular line is going to have a negative slope. And then the reciprocal means I'm going to switch my numerator and denominator. So I'm going to have -2 over 1x. And again, this plus could be plus anything. I could have plus 327, and that's going to be a perpendicular line. So hopefully you guys remember parallel, we have the same slope, perpendicular, opposite, reciprocal, change the sign, flip the number. Okay, so what we're going to do is now we're going to take a look and we're going to show that a shape is something for sure. So in number 1, we're showing that ABCD is a trapezoid. So the first thing that we have to know is what does it mean to be a trapezoid? So if you guys want to have your notes out by you so that you can be looking at these definitions, a trapezoid, we need at least one pair of parallel sides. Okay, so one pair of our opposite sides need to be parallel. So in this image, we want to show that one pair of our opposite sides are parallel. So when I'm looking at this, I can kind of use my best guess to see which ones do I think might be parallel. If I'm wanting to show that this is a trapezoid, the two sides that I'm going to say might be parallel would be side AB and side DC. Okay, so in order to show that these are parallel, there's a couple different ways that I can do it. So we can do our counting method where I count from A to B, I go up to over 3 and say that the slope of segment AB is my rise of 2, my run of 3. And then the slope of CD would be I rise 1, 2, 3, 4, and I go over 1, 2, 3, 4, 5, 6. So 4 over 6, which simplifies to 2/3. And when I look, those two are the same. So I do have parallel lines. The other way that we can do this, and I just want to show both ways so that we have them, is if I look at all of my points, and I'm going to find the coordinates of all of my points. A is at -1, 1. B is at 2, 3. C is at 3, 1. And D is at -3, -3. And I could use that slope formula that I found earlier to find the slope of AB. So I would do y2, which is 3, minus y1, which is 1, over x2, which is 2, minus y2, which is -1. So 3 minus 1 is 2. 2 minus -1 is the same as 2 plus 1. I get 3. And I could do the same thing with the slope of CD. My y2, so -3 minus 1 over my x2 minus x1, so -3 minus 3. -3 minus 1 is -4. -3 minus 3 is -6. This simplifies to 2/3. And both ways that I do that, I get the slopes are the same. So my sides are parallel. So this is a trapezoid. Okay, so the next problem, 1B, says find the coordinates of the mid-segment of the trapezoid. So we did talk a little bit about on Tuesday about the mid-segment, is we're looking for that point that is right in the middle of the two pieces. So mid-segment connects my two midpoints. So I have to be able to find the midpoint, and I'm going to change colors. There's a lot of green going on right now. So we have to be able to find the midpoint. So my midpoint formula, if you guys remember, right, midpoint, I'm going to do my, oh, my computer keeps zooming in and out. Okay, I'm going to do, oh, okay, x1 plus x2 divided by 2, and y1 plus y2 divided by 2. And that's going to give me the midpoint of my lines. So just like with that slope formula, x1, x2, y1, y2, that's just talking about the coordinates of certain points. All right, and so I'm going to continue to use these coordinates of A, B, C, D that I found over on the left. If I'm wanting to find the mid segment of the trapezoid, it's going to be a line that runs between my two parallel lines of AB and CD. So that means I'm going to have to find the midpoint. Oh, hold on. The midpoint of AD and the midpoint of BC. So this is different. I'm not going to find the midpoint of my two parallel lines. I'm going to find the midpoint of the two legs of my trapezoid. So the midpoint of AD, I'm going to need to add my x values and divide by 2. So A was at -1, D was at -3. And then my y values, I have 1 plus -3 divided by 2. And when I simplify this, -1 plus -3 is -4 divided by 2. 1 plus -3 is -2 divided by 2. So my midpoint of AD, I would get -2, -1. Same thing for BC. I'm going to add my x values, so 2 plus 3 divided by 2. Add my y values, 3 plus 1 divided by 2. So I get 5 divided by 2. And 3 plus 1 is 4 divided by 2, which is 2. I'm actually just going to write that as 4 divided by 2 for right now. And then if I simplify both of those, 5 divided by 2 is 2.5. 4 divided by 2 is 2. So I can go ahead and mark those 2 points on my graph. So -2, -1, and 2.5, and 2. And if I connect those 2 points, that will give me the mid segment of ABCD. And when I say the coordinates of the mid segment of the trapezoid, we're looking at these 2 midpoint coordinates. All right, the next thing, we want to show that let's try that again. We want to show that PQRS is a parallelogram. So we have to figure out what makes something a parallelogram. Well, a parallelogram, we have that our opposite sides are parallel. So that's what we're going to have to show here. So my opposite sides, I have to show that PQ is parallel to SR. And I'm also going to have to show that PS is parallel to QR. And I'm just writing those down so that I can refer back and make sure that when I'm done, those are the 2 things that I've proven. Now again, proving that 2 things are parallel, how am I going to do that? Well, I'm going to find the slopes of those 2 lines and check and make sure that those are the same. So if I want to find the slope of PQ, I'm going to use my slope formula. So I'm going to need to know the coordinates. So I'm going to go ahead and write those off to the side here. P, Q, R, and S. So P is -3, 4. Q is at 1, 2. R is at 3, -2. And S is at -1, 0. Okay, so to find the slope of PQ, I'm going to do my y2 minus y1 over x2 minus x1. So PQ, I'm going to do 2 minus 4 over 1 minus -3. So 2 minus 4 is -2. 1 minus -3 is the same as 1 plus 3. So I get -2 over 4 or -1/2. Okay, and I'm wanting to show that that is the same slope as SR. So the next one I'm going to find is the slope of SR. So y2 minus y1 over x2 minus x1. I'm going to do -2 minus 0 over 3 minus -1. -2 minus 0 is -2. 3 minus -1 is the same as 3 plus 1. So -2 over 4, which is the same as -1/2. So right now I have -1/2 for both slopes. So I have proven that PQ is parallel to SR. So I'm halfway there. Okay. The next one is I need to find the slope of PS because I need to prove that PS is parallel to QR. All right, PS, so I need to do 0 minus 4 over -1 minus -3. 0 minus 4 is -4. -1 minus -3 is the same as -1 plus 3, so 2. So the slope here is going to be -2 over 1. All right, now the slope of QR. All right, so QR, I'm going to do y2 minus y1, x2 minus x1. So -2 minus 2 over 3 minus 1. -2 minus 2 is -4. 3 minus 1 is 2, which simplifies to -2 over 1. And again, those two slopes for PS and QR are the same. So I've proven the second piece, that PS is parallel to QR. And I have proven that both sets of opposite sides are parallel. So I do have that PQRS is a parallelogram. So really with this, there's a lot of small steps that go into it, but really what we're trying to prove is some pretty straightforward ideas. We're just proving lines parallel, which we've done tons of times before. So now let's talk about, okay, a rectangle. So a rectangle is going to be something a little bit different because what is the definition of a rectangle? So a rectangle, we have to show that it is a parallelogram and there are 4 right angles. So even more specifically, to show that something's a parallelogram, what we're actually going to have to prove, I'm going to write this off to the side. I have to prove that both pairs of opposite sides are parallel, and I have to prove that all four of my angles are right angles, or that all of my lines are perpendicular to one another. So in rectangle DEFG, I'm going to have to prove that DE is parallel to GF. I'm going to have to prove that DG is parallel to EF. I'm going to have to prove that DE is perpendicular to DG, and that it's perpendicular to EF. And I'm also going to have to prove that GF is perpendicular to DG and EF. So looking right here, I have to prove that 6 different things are true. So let's go ahead and get started on these first pieces. So the first thing that I need to know are what are the coordinates of my 4 points. So D, E, F, G. So D is at -2, 3. E is at 4, -1. F is at 2, -4. And G is at -4, 0. So when I'm proving that lines are parallel, I'm going to have to find the slopes of all 4 sides. So I'm going to have to find the slope of, oh no, we're deleting words now. Okay, I'm going to have to find the slope of DE. I'm going to have to find the slope of GF, of DG, and of EF. So hopefully you guys are comfortable now finding those slopes again. So what I want you guys to do is I want you guys to pause the video, and I want you to find all 4 of these slopes on your own. Because what I'm going to do is I'm just going to very, very quickly find all of the slopes. But I want you guys to practice and make sure you can do it on your own first. So go ahead and do that. Pause the video, find these slopes, and then go ahead and come back. All right. So I am going to find DE. So I'm doing -1 minus 3 over 4 minus -2, which is -2/3. GF, I am doing -4 minus 0 over 2 minus -4, which is -2/3. DG, I'm doing 0 minus 3 over -4 minus -2, which is 3/2. And EF, I'm doing -4 minus -1 over 2 minus 4, which again is 3/2. Okay, so hopefully you guys paused the video, you guys got the same answers that I did when I kind of quickly went through everything. So Now that we have all of the slopes, now I have to check and see if all 6 of these things are true. So the first thing is DE parallel to GF? So are those two slopes the same? Well, if we look, they absolutely are the same. They're both negative 2/3. Check, top one is done. Next is DE parallel to EF. DG, I'm sorry. They are both 3/2, so absolutely that second one is correct. All right, so this is the perpendicular piece. So remember, perpendicular means that we have to have that opposite reciprocal. So I'm going to just kind of write this off to the side. So that means that I have to have my opposite reciprocal. So if I have DE, if I'm looking at DE here and I want to see if DG is perpendicular, are negative 2/3 and 3/2 opposite reciprocals? They absolutely are. So we are good here. All right. Oh, without deleting everything. Okay. And now DE and EF. So DE and EF, negative 2/3 and 3/2. Check. GF and DG, negative 2/3 and 3/2. Again, we do have opposite reciprocals. And then GF and EF, negative 2/3 and 3/2. Those are perpendicular. So since we showed that all 6 of these were true, we did show that this is a rectangle. All right, so what I want you guys to do is I want you guys to stop and I want you to try on your own number 4 and number 5. So show that these are so show for number 4 that JKLM is a trapezoid, and show for number 5 that ABCD is a parallelogram. So we have done 2 examples just like these ones. So hopefully you guys are going to be able to figure out first what you need to show, and second, be able to show it. So pause the video again, try these, and then I will go through them with you. Okay, so number 4, show that this is a trapezoid. So if I'm wanting to show that JKLM is a trapezoid, I need to show that 2 sides are parallel. So one pair of opposite sides are parallel. When I'm looking at this trapezoid on the graph, the 2 sides that I think look parallel just by looking at them would be LM and JK. So those are the 2 that I'm going to try first. So I'm going to try to show that LM is parallel to JK. And if this doesn't work, I also will want to try JM and KL and make sure that those aren't parallel. But let's try these ones first. So first, I need to, what are the coordinates of all 4? So J, K, L, M. J is at negative 2, 3. K is at 4, 1. L is at negative 1, 0. And M is at negative 4, 1. Okay, so the slope of LM all right, so I am going to find my slope really quick. So I'm going to do 1 minus 0 over negative 4 minus negative 1, which 1 minus 0 is 1, -4 minus -1 is the same as -4 plus 1, which would be -3. And then JK, and my y2 minus y1 over x2 minus x1. So I'm going to do I'm going to do 1 minus 3 over 4 minus -2. 1 minus 3 is -2. 4 minus -2 is the same as 4 plus 2, which is 6. And this is the same as -1/3. Well, right now I have 1 over -3, and I have -1 over 3. But remember, when we write slopes, we always want to write the negative with our numerator, just so that we are consistent throughout. So I want to rewrite LM, that slope, as -1 over 3. And now I do have the same slope for both, so I did show that LM is parallel to JK. All right, perfect. All right, number 5, we have a parallelogram. So I want to show that both pairs of opposite sides are parallel. So my opposite sides, I want to show that AB is parallel to its opposite side of CD. And I want to show that BC is parallel to its opposite side of AD. All right, so I'm going to go ahead and find each of my points, A, B, C, and D. So A is at -3, -2. B is at 1, 4. C is at 2, 2. And D is at -2, -4. All right, so the two slopes that I need to find, or I need to find 4 slopes actually. I need to find AB, I need to find CD, I need to find BC, and I need to find AD. I need to find all of these slopes. Okay, so the slope of AB, so I'm going to do y2 minus y1 over x2 minus x1. So 4 minus -2 over 1 minus -3. So minus a negative, I'm going to do 4 plus 2, which is 6. And I'm going to do 1 minus -3 or 1 plus 3, which is 4. And I can simplify this into 3 halves. All right, CD, I'm going to do the same thing. So I'm going to do -4 minus 2 over -2 minus 2. -4 minus 2 is -6. -2 minus 2 is -4. So my negatives are going to cancel out, and so 6/4 simplifies down to 3 halves. So if we look, those two slopes are the same. So I did prove that AB is parallel to CD. Perfect. All right, so now I need to do that BC is parallel to AD. So the slope of BC, I'm going to do 2 minus 4 over 2 minus 1. And get that 2 minus 4 is -2. 2 minus 1 is 1. So my slope is -2 over 1. And then AD, I'm going to have -4 minus -2 over -2 minus -3. -4 minus -2 is the same as -4 plus 2, which is negative 2. Negative 2 minus negative 3 is the same as negative 2 plus 3, which is 1. And these two slopes match. So I did show that BC is parallel to AD. And I just realized I have not been using segment lines. So remember that when we're talking about things being parallel, things being perpendicular, we do need to refer to them as segments. But Miss Winkle apparently is being lazy and did not do that. All right, so I'm going to have you guys just practice some more with these coordinate planes and showing that quadrilaterals are specific shapes. Tomorrow, just so you guys kind of know what the plan is we're going to be reviewing all of these properties. We're going to review some of these coordinate plane ideas, and then I'm going to have you guys take your first formative. We're going to try some different things on how we're going to have you guys turn in formatives. So bear with me if tomorrow is a little rough. Just go ahead and do your best. Just make sure that we get that turned in. That way we can give you guys some feedback just like we usually do with formatives. All right, have a good rest of your day, guys.